So the reason I want to jump into a quick part two of this is as I continued looking at the topic of treating or labeling sugar as an addiction, as an addictive chemical, or even food addiction, I didn't realize there was quite a controversy. There seems to be a little bit of a territorial battle, and I ran into that with this particular review. It's more of a review paper or article. But I think it really kind of sets it up to a place where we could probably just call it quits after this and decide where we individually want to end up. So let me get to the study itself first. I should have changed this title slide, neuropsychosocial addiction. I should have added evolutionary to this because that's where they started with this paper. So sugar addiction from evolution to revolution. And this is a pretty lengthy review article. Two of these researchers are from a medical school, one's from a school of public health, and they really come at it from a psychological perspective. So that's going to inform as to their position and why they're coming down, where they did. Last week, which I'll reference a little bit, they really hit the biochemistry hard. They looked at the DSM, they looked at the qualifiers for calling something an addictive chemical, and they simply said, based on these research studies, these clinical trials, these mechanistic metrics, sugar does not fall into a category of an addictive substance, but certainly we can call it a topic of dependence. So behavioral dependence rather than chemical addiction. So we talked about that a little bit and what those nuances mean behaviorally. And that's really what these guys talked about. In this particular paper was written, I believe, let's see, was it 2000 and no, maybe the one we did
18.
last week. The one we covered last week was like 2010, where they went through all the mechanistic elements of why sugar, in their opinion, should not be classified as an addictive substance, a chemical. These guys came along later and they're punching back pretty hard, saying, we think it should be considered addictive. And they talk about the food addiction model as something to juxtapose against something mechanistic like this. So, as I said, they start with evolution, and I don't want to say it's disappointing in a way that it's inferior, but they really do just rely on a lot of logic and statements like we feel, um, and wouldn't it be better if, instead of the true hardcore type of research that you might feel better about. But they did start with evolution. And let me read some of this. I'm gonna slow down a little bit on some of these things because I think their narration is pretty important. The obesity epidemic has been widely publicized in the media worldwide. Investigators at all levels have been looking for factors that have contributed to the development of this epidemic. Two major theories have been proposed: sedentary lifestyle and variety and ease of inexpensive, highly palatable foods. In the present review, we analyze how nutrients like sugar are often used to make foods more appealing, could also lead to habituation, and in some cases, addiction. So, two phrases we talked a lot about last time: habit versus addiction, thereby uniquely contributing to the obesity epidemic. We review the evolutionary aspects of feeding and how they shape the human brain to function in survival mode, quote unquote, signaling to eat as much as you can while you can. This leads to our present understanding of how the dopaminergic system is involved in reward and its functions in hedonistic rewards. So another thing that we juxtaposed last time, um, the drive of just liking something or it making you feel good, sating you hedonistically without some of those biochemical shut-off mechanisms. Um, we also review how other neurotransmitters like acetylcholine interact in the satiation process to counteract the dopamine system. Lastly, we analyze the important question of whether there's sufficient empirical evidence of sugar addiction, again, a chemical phenomena, discussed within the broader context of food addiction. So it's really, I mean, a lot of this language is set up to shoot directly at what we talked about last time. While behavioral and lifestyle interventions remain the mainstream treatment approach for obesity, dietary adherence remains an obstacle. The reason I'm reading a lot of this stuff in these long segments is it's really, really important for some of the things we talk about all the time. And I'm going to come back to some of these. Recent research suggests that highly processed foods are addictive, and the hedonic mechanisms, pleasure-seeking pathways, may play a critical role in the pathogenesis of obesity. It has been suggested that the focus on calorie counting is misguided, and that future strategies should emphasize dietary quality, so more intuitive eating, and individual factors such as hormonal regulation, metabolism, and the gut microbiome. I'm going to come back to some of this stuff and pick it apart because, again, this is what I meant when I said they really hit on a lot of things we discuss often here. Given the challenges that many people face controlling their appetites in today's food environment, it appears that public policy changes will be required to modify the conditions in which food choices are made. According to Gerhard Brownell, it will be important to look at a widespread subclinical impact of potentially addictive foods through the use of public health approaches. So again, public health, very different field than looking at, random control trials, et cetera. The goal of this paper is to review the human predilection for refined sugars and how they reshape the brain, which with its implications for public health policy. Now, let me come back and talk about this one sentence in particular, because they say recent research suggests that highly processed foods are addictive and the hedonic mechanisms, which again, I go back to last week, can be two different things. I know Kevin and Dr. Souders may want to weigh in on some of this, but it's not that you can't have both and that both can't play a part, that you can't have a chemical addiction and just habitual integration of something, but sometimes they can be separate, and that may be important with this. I thought for these particular people writing this paper, yeah, I mean, maybe it's okay. I mean, I don't want to say that they're just playing fast and loose, but to dig into more metabolic science and make some broad statements, it makes me want to at least point them out. That research suggests that both of these are addictive and hedonic, but also that the focus on calorie counting is misguided. We've covered that quite a many different ways, in that that future strategies should emphasize dietary quality and individual factors such as hormonal regulation and gut microbiome. Man, we have talked a lot about these, and I can't say that any one of those would be the answer. I've just done 2 or 3 major appearances on podcasts and our own work on hormones, going through the different classifications of hormones and how they impact fat loss, fat gain, that sort of thing. Would love to answer some of those questions if you guys have them. Gut microbiome is a very large field of interest now, growing. Not a lot of answers there, but certainly uncovering a lot of questions. I don't think that is necessarily the primary focus where we should be for obesity. We've talked ad nauseum about the pros and cons of tracking food carefully, calorie counting. And I will unapologetically say forever and ever and ever and ever that for those people who really like detail and analytics, they may score high personality-wise on conscientiousness and neuroticism, that could be a level to start because they love that. I mean, that's their jam is detail. But if you don't get to the qualitative side and you don't integrate those things into intrinsic values, those people will just fall and fall and fall and fail over and over and over. Consequently, the other side, somebody who is just not attracted to that kind of detail, if they never get to the point, if they just go by quality and they just go by intuitive eating protocols, because they never get that dogmatic quantitative information in their brain, they never learn the mathematical language of nutrition, they're also going to fall and fail repetitively. So, I didn't like this, that they kind of juxtapose it as one or the other. You just have to have both. You really just have to have both. So moving on here, let's talk about the genetics, because I want to get into some of the evolutions. Adipose tissue in mammals play an important role in survival by preparing the body for periods of famine. From an evolutionary perspective, the increase in body fat preparedness or prepares animals for times of scarcity. However, this occurred in times when humans had insecure food supply, hunter-gatherer, and could spend many days on a hypocaloric diet. During prehistoric times, the excessive increase in body weight was dampened by physical activity needed in the search of food. Moreover, excessive fat would mean, as a predator, lower chance of catching prey and vice versa. So even if copious quantities of food were eaten, there was a natural break mediated by physical activity. This is a really, 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 really pedantic distillation of evolution. If you start with the broader themes that, like a great white shark, our ancestors had to spend a lot more energy looking for food, that's absolutely true, but not always. You can look at, Australopithecus afarensis, one of the main transitional figures from our Homo genus, on backwards. And they survived for about 1 million years, one of the longest runs of any species, because they were in a place where food was plentiful. Then is it the Palatine, the Ice Age that really kind of, started from the North Pole and came down and pushed, a lot of different species into different types of evolution. It changes everything. And one of the things that I want to point out because of this assertion, some of these changes, like if you look at Homo habilis, coming right from the Australopithecus line, and you say, well, okay, look at these feet, for example. These were made to still, climb versus a lot of plantar flexion and natural bipedal gait and all this. Those sometimes take 1 to 3 million years. And that's not like just snapping your fingers and saying there was this major change. But then you look when there was a lot of evolutionary pressure, like from Homo erectus to Homo sapien, you may see massive changes in 100,000 or 200,000 years. But these guys are talking about changes that we're seeing by decades, by the 1960s, by even if you go back to 10,000 years ago when we started an agrarian type of culture. So I just think it's worth noting that you can't pin the things that we are struggling with on, you know, just certain periods of evolution like they did here. Um, One of the things I think is very notable, we talked about epigenetics last time. When you do see those rapid changes, here's where I concede this point. We are not catching up. You're going to see the fact that we have moved in just the last 100 years or 200 years through major shifts, and evolution has prepared us for much more resistance to famine and so forth. That's all very true. But then they turn around and they make kind of the antithetical argument when it comes to treating this as an addiction, that therefore we would evolve instantly to be able to have these kinds of chemical addictions, which I think actually favors last week's argument. And that's why we probably haven't seen some of the chemical addiction crossover yet neurochemically. But that doesn't mean it won't come. It just may take another 100,000 years. So let me get through some of this detailed stuff, and then I want to get to some of where I think their arguments really do give us a chance to kind of blend these two positions. Although humans have culturally and technologically evolved, our genome has changed very little in the last 10,000 years. This means that our brain circuitry is still programmed to eat more in times of food abundance, preparing for food for periods of starvation. Recent genetic studies have focused on gene polymorphisms related to specific nutrients and obesity. Um, so this is what I mean by they're almost wanting their cake and to eat it too. Um, the brain circuitry can evolve pretty quickly. I mean, we do see that with epigenetics. But then to say it's the same as it was 10,000 years ago, what if it was the same as it was 100,000 years ago, or the same as it was 3 million years ago? There are some things you can tell, with DNA testing and all of the things that go into archaeology and anthropology, and some things that you just can't. So let me move on, and I'm going to pull some of these things together here. The neural circuits for reward, various neurotransmitters in the circuit, like GABA, glutamate, and opioids, are involved in several aspects of reward. However, the dopaminergic pathway from the ventral tegmental area to the nucleus accumbens has received the most attention in the reward cascade. To summarize, blocking the dopaminergic pathway between the ventral tegmental area and the nucleus accumbens inhibits instrumental responding for food and became the foundation of the dopamine hypothesis of reward. Later studies have demonstrated that reward is a vague term that consists of at least three components, back to the hedonics or the liking, the reinforcement or learning, which is going to be the habit, and motivation, which could be tied back to the chemical. So here's another place where I think it's important to kind of at least put a stake down in the chronology of what we're trying to cover. And they discuss the differences in the hedonics versus this chemical drive. But then you're going to see in a couple later slides that they want to say that we can't control it because it's 100% chemical. Yet that has been improven because we're gonna talk a little bit more about how they get into the shutoff mechanisms. So just to discuss that now, if you go back to that point there, to summarize, the blocking of the dopaminergic pathway between the VTA and the nucleus accumbens is instrumental. So they said because of our evolutionary background, we have this drive to eat as much food as we can when it's there, as if there's no shutoff. But then here they describe exactly where that chemical shutoff is. We actually do have those in place. Those are also evolutionarily important. I don't even know if I would ascribe it to the anthropology that, they mentioned that if you have just way too much body fat, like imagine right now with 70% of us sedentary, overweight, or obese, and now we're all out in the open just trying to survive as hunter-gatherers with predators, with natural predators, saber-toothed tigers and so forth. Like how many of us as chubby little sedentary unathletic people would survive, right? So there is evolutionary pressure, not just for you to be able to seek, to hunt, to gather, to find food, but then also to maintain a homeostatic balance, because just through natural selection, the parts of a society that were stronger, quicker, more athletic, maintained that metabolic homeostasis, they would be the survivors to pass on their genetics. So again, this being more of a position paper by public health people in med schools trying to teach toward a better outcome in society, I think they're kind of stretching in trying to have their both ways here. So neural circuits for reward, continuing on. Similarly, lever pressing for food pellets in animals increase dopamine, especially from the accumbens, nucleus accumbens release. However, not during rat chow feeding. This is an important slide. So let's take this line by line. Lever pressing for food pellets in animals increases dopamine, but not during normal food. It's like we were talking off camera about our dogs, Kevin and mine. My dog didn't get excited about her just raw food, right? Like you get the bag from Rural King and you're putting that in her bowl. Like who cares? She could just walk away from it. But as soon as I got out the canned stuff or whatever, we mix that in there, all of a sudden she's dancing around, salivating. Similarly with animals, there is a novelty aspect to this. It's not that even our primitive ancestors would have gotten just so excited about gnawing on raw acorns, right? Like, okay, I guess if I have to survive, but I'm not going to binge on these. But if they found a fruit tree, and we saw this like in Chimp Empire on Netflix, like then they would employ a little bit more gluttony. Others have observed that the nucleus accumbens dopamine increases rat chow feeding only if the rats were food deprived or in the presence of palatable foods. Interestingly, increased dopamine with highly palatable food wanes after repeated exposure. So this is a normal part of that shutoff. If this were just chemically driven, that wouldn't happen. That was part of last week's information. Suggesting a role of neurotransmitters for the nucleus accumbens for novelty recognition. Additionally, it's been shown that dopamine neurons respond to exposure of a novel food if the novel food is paired with a cue. So now again, habit. Now we're getting a little bit Pavlovian. Now we start relating this food, this decadence with that one time that my spouse gave it to me on our first date or something. Like now we're pulling in some psychology that can, but doesn't necessarily have to go along with chemical addiction. It appears that nucleus or that accumbens dopamine plays more of a role of anticipation, that anticipatory behavior, than in the consumatory behavior. Stomach-derived ghrelin has known action on orox. I can't read that last word because this box is in the way here. Sorry about that. Neurons in the hypothalamus, while receptors have been identified in the ventral tegmental area, hippocampus, and amygdala. Ghrelin appears to be implicated in rewarding aspects of eating distinct from homeostatic mechanisms that promote food consumption when energy stores are low, thus may be a key driver in the motivation aspects, the wanting, beyond metabolic needs. So again, it's interesting that they do draw the or they don't draw the line. They show the difference between habit forming and hedonic wanting or liking, hedonic wanting or liking versus the chemical drive. And that's going to get to a point here in a minute that they do tie it together. Finally, pharmacological manipulation of the dopamine system has led to contradictory results. On one hand, dopamine injected directly into the nucleus accumbens is capable of increasing ingestive behavior. However, others have not been able to modify feeding behavior when specific DA agonists or antagonists were used. This starts making the argument for the other team in that it just doesn't always work. It doesn't always work for some people. Some people, seem to find this, they seem to have a higher propensity, and they're going to get into some of the genetic reasons why. Maybe that doesn't really discount chemical addiction because I think we all have some baseline or basal perfunctory equipment, hardwiring for addiction in general or different kinds of addiction. Human studies using neuroimaging determined that obese patients had a lower sensitivity to the accumbens dopamine and a decrease of the DA-D2 receptor availability. Several studies have used the term reward deficiency syndrome to describe a genetic dysfunction of those receptors, leading to substance-seeking food or behavior in humans. Variations of the gene have also been associated with impulsivity and a preference for smaller, more immediate rewards compared to larger but delayed ones, delayed discounting. Stanford Marshmallow Study. It is possible that obese patients compensate for the depressed dopamine basal levels by overeating palatable foods. Conversely, optogenetic induced increases in basal dopamine release inhibits consumption behavior. How can these results be reconciled with other studies? Dopamine is relatively phasically or tonically and tonically with possible divergent tasks. Basal dopamine levels are likely to determine the tonic response of the system, thus could confer a complete opposite response. So again, I kind of corrected myself on that last slide. I don't think this necessarily changes from it can't be a chemical addiction. Some of us just have different circuitry. So yeah, I'm just going to leave it there so I can make sure we have time to discuss. Acetylcholine. So now we're getting into some of the chemical drivers of this dopaminergic system, especially the braking mechanism, the ability to stop a behavior. Acetylcholine in the nucleus accumbens appears to have a modulatory effect on feeding behavior. During free feeding, acetylcholine increased at the end of a meal, and during ingestion of a palatable food, it reached maximum after the animal stopped eating. So this is where we have the chemistry to pump the brakes to say, hey, even though that was good food, nutritious food, even though you could be in precarious contexts where food is insecure, there is an end game here physically. Like more of this food right now is just not gonna be to your best interest. That is chemically driven. Drugs of addiction exert differential responses on the accumbens cholinergic interneuron. One could separate these drugs by their effect on feeding. For example, a release is decreased or not changed in the nucleus accumbens if the drug increases food intake, and that goes into highly addictive substances, opioids, alcohol, benzodiazepines, while those that act as anorectic, like some foods or chemicals of high drug addiction actually reduce appetite, like cocaine, acetaminophen, nicotine. And so, they can have the opposite effect. So can we have chemicals that cause us to eat more or to, cause us to eat less? If we were going to bank all of this on evolution, what would the benefit be? That's at least one way to look at evolutionary drives. So now they're going to kind of end with this. Can we actually say that food is a drug of addiction? Is there a difference between food addiction and drug addiction? First, feeding behavior, as with other natural behaviors, has a satiety system provided by the mechanical limitations of the stomach and peptides like CCK that signal satiety, while drugs of addiction apparently do not. Secondly, even in the presence of a palatable meal, the pleasant effect seems to wane simultaneously to a blunting of the dopamine response, even though in some cases, sensory-specific satiety can lead to continued consumption behavior after a novel food is introduced. Finally, the magnitude of dopamine increase is lower during a meal than during drug administration. Drugs of abuse not only release striatal dopamine, but also block or reverse dopamine. So again, there's kind of a breaking effect. This is why I brought up in our last episode on this, the movie The Whale. I just haven't really seen Hollywood take on this like they did in that movie. And it was a man who had eaten himself from a very normal weight. He was married, had a child, was a college professor, and then the whole movie was all of a sudden he's 6, 7, 800 pounds, wheelchair bound, and they very specifically, obviously in the direction and the production of the movie, they wanted to show at least the struggle and the humane side. Remember, this is Hollywood, so they're gonna probably err on the side of showing acceptance and the fact that this isn't necessarily by choice. This we classify obesity as a disease process because of papers like this. And so they show this guy who is clearly not hungry, eating just massive amounts of food, 2 large pizzas, just massive multiple, meatball strombolis, where he's probably eating 5 pounds of meat. And everything in the normal human chemical addiction model would say there has to be a stopping point if we're going to tie this to something that's evolutionarily worthwhile, food, nutrition for survival. Then you bring in these chemicals of addiction, and you would say, well, if heroin, if opioids, if nicotine, if alcohol, if those were so good for us, why can we consume them to our death, to our peril? So clearly, we have created these foods, and this is the tie-in that I think is important. We have created these chemicals. We have learned how to synthesize them into dosing responses that we can just overconsume to our death. And their point is we have now done the same with food. You can't find Twinkies growing on a Twinkie tree. You can't find the kind of sugar in the food that is so highly palatable out in nature. And so just like these chemicals of addiction that will lead us right off of a cliff, food is now doing that as well. So I'm trying to bring this back to a point where I think we can all agree on a little bit of just syntax and semantics. But I still want to end up showing where there may be some physical differentiations, at least now in this point of our evolution. So here's from last week. So this was last week's major discussion point. It brings down the discussion, the premise, the whole reason they wanted to do this. The purpose of this review, and remember, their review was to show pharmacologically that sugar is not an addictive chemical. It's not physiologically addictive. The purpose of this review is not to suggest that the widespread and cheap provision of palatable foods has not played a role in the increasing incidence of obesity. Rather, it is important that the underlying mechanisms are understood so that this knowledge can generate appropriate responses. If addiction to sucrose plays an important role in the development of obesity, then various conclusions will follow. If it was a chemical addiction, then we got to have certain protocols. If it is falsely believed that sucrose is addictive, then inappropriate responses will be made and helpful behavior will be avoided. Already, some have been worried that dieting may not be the best solution if it generates cravings and withdrawal symptoms. If sucrose is the villain that attempts to deal with obesity should concentrate on this ingredient. If sucrose is not the central villain, then inappropriately concentrating on this food item will ensure that the most beneficial responses will be ignored. This is so important. Look what we did with nicotine. Of course, we haven't banned it. I think some countries have, but at least you have to be like 21. Alcohol, same thing. Where maybe RFK Jr. This is kind of a big deal in the closing arguments in this particular election cycle. Maybe he will come in and say, now sugar is the enemy. We're going to outlaw it. But to these researchers' premise point, if sucralose is chemically addictive, we have to treat it that way. We have to make movements in that direction. The whole reason they described it not being chemically addictive was so that we can then start looking at some of the behavioral aspects, the hedonic aspects, and learn how to control it that way. Because if it's pure heroin, then, I mean, will Narcan work? Would different things like that work? Here's what's interesting. Now let's read this week's conclusion. The food addiction framework for understanding obesity is the notion that highly processed, hyper-palatable foods have hijacked the reward centers in the brain, thus impairing the decision-making process, similar to drugs of abuse. The major assumption is that biochemistry drives behavior. The sugar addiction theory bridges current gaps between food science and neuroscience and between nutrition and psychology. This theory was originally developed from animal studies. However, there is no shortage of compelling human data. While food addiction has been sensationalized in the popular press with headlines such as Oreos are more addictive than cocaine, we propose that processed food addiction in humans is more like caffeine or nicotine addiction than it is cocaine or heroin. There is a subtlety to food addiction where a significant majority of people who meet the criteria may not be aware of it, likely because it is not widely accepted as a social norm. Meanwhile, there have been non-clinical recovery movements of self-identified food addicts dating back as far as 1960s when Overeaters Anonymous was formed. So, man, when you put these two statements side by side, you see that they're just not that far apart, right? Uh, if we go back up to the original response of last week, where they were dogmatically saying this is not a chemical addiction, they start off by saying, well, look, obesity is a thing. Obesity is killing us. Like, we know we have to address it. We just want to make sure we're addressing it the right way. If we are wrong, and this is a chemical addiction, then we have to just throw dieting away, all the other modifications away, and we have to treat it like an addiction. Then you come to this week and they kind of back off a little bit and they say, well, it's an addiction, but it's kind of like caffeine. Like, are you really addicted? Well, no, not really. You just like it. So they kind of backed all the way off after 300 citations in this position paper that they want to drive a total change in public policy. And I think they just completely stepped back into a very reasonable position where it doesn't necessarily oppose last week's conclusion in that, well, if it's just kind of like caffeine or, something else, then maybe it is more hedonic. Maybe it is more our liking and our wanting, like an actual behavioral dependence, not a chemical, actual addictive, biochemical mechanism. But again, I think perhaps we're just not there from an evolutionary perspective. So maybe at some point in 1,000 years, in 10,000 years, 100,000 years, if our species existed in the same form, because of even more and more and more hyper palatable food, maybe it would cross a line and our biochemistry could change. So I'm gonna save some of my closing thoughts to merge with you guys because I know that you'll have some great catches and corrections and advancements. Let me stop the share here, and you guys feel free to unmute and jump in with comments or questions. Thought I stopped the share, and it did not stop the share. Is it not sharing, Kevin? Or is it still sharing?
Still sharing.
Hmm. Says I'm not. Anyway, Kevin, what are your thoughts? And then we'll go to Dr. Souders as well.
Um, I'm biased. There you go. You stop sharing. I'm biased in towards of what the general consensus is that it's not truly addictive. Much like what you said, I would say there's a dependence, which maybe slash out with habitual tendencies, whatever that may be, but and maybe dependence is still too strong of a term to define sugar or foods of nutrition in that way. But there is a drive of that tendency to enjoy those such foods. But I assure you, I'm not in an alleyway trying to get sugar because I'm so addictive to it. I'm not driven to that need to do. I guess I could rob and do something illegal to acquire it, but it's not because of sugar, probably. I don't know. But I'm just making that far-fetched example of, to me, that's how a, like a far delineation of behavioral
But
efforts I could do.
people with binge eating disorder, and this came into play last week, they might say I would do that. I have clients who have um been in kind of a binging episode, and so they go through their house and they just clear out all their cabinets, they throw all their food in their garbage can. One client even sprayed down cookies in the garbage with Windex so she wouldn't eat them. And she
Yeah.
had her husband put padlocks on the cabinets in the refrigerator. And then she still got in her car and went and drove to get fast food. So,
Mhm.
this is where, like last week, when I said, well, okay, we may mechanistically be able to say it's not a chemical derived thing. But even this week, we showed, well, even that hardwiring can change so that we are a little bit, some people are more susceptible.
True.
So, I mean, that's where I came down last week to say, well, even if it's habitual dependence, chemical dependence versus chemical addiction, like, man, for a lot of people, you wouldn't be able to tell the difference.
Yeah. I don't know then.
It just shows the extremes, right? Those opposite poles.
Hmm.
What do you think, Jen, our
Well,
addiction specialist?
um, I, I, it's complicated, right? I think just as, looking at this and looking at these two papers in contrast, I don't think that sucrose, sugar by itself is really behaving like an addictive substance. Where I do find interest is this idea of the highly palatable foods. I've read a number of books, and I would have to go back to my library and tell you which ones were the most influential. But when you look at how the food chemistry industry has had focus groups and how they have literally worked so hard to design optimized chemicals that trigger the responses in human consumer panels that they want. That, this is the best thing. So I see some similarities there between designer chemicals in the food science industry and designer chemicals that do promote addiction. I think there's a big difference between a nutritive thing like sucrose and a non-nutritive like a chemical. Um, and I think that seems to be just, and I don't have a practice seeing people with food addiction, um, not as a primary thing or anything like that. But, just in general, studying these disorders and, reading about this and us discussing it and all the people that, are part of this this group that we work with. Um, it seems to me like the binges are pretty much really around these hyper palatable foods. And I think it was really interesting last week, when we talked about it, there was also texture and, the salt sweet and those kinds of things. So those things are all built into the wanting and what is the, the hedonic drive. So I see the chemistry as being pretty important because that's the novel thing in our society. Until very recently, even if we had access to a whole lot of Toll House cookies in the turn of the last century, we also didn't have access to the chemical flavorings and things that are involved with some of the like the chips and are even used now in like fast food in order to enhance the flavorings of the say the buns and the fries and the the sauces and all that sort of thing. I'll just share a little anecdote. It was kind of interesting that this weekend, I'd gotten the bags of candy to give out on Halloween. I'm rocking my Halloween stuff this week. But I decided on Saturday evening I was gonna have a piece of Halloween candy because, like, you know. So I picked out a fun-sized package of Starburst, and my first reaction upon eating it, I cannot recall the last time I ate a Starburst. I literally cannot remember when it was. Probably when I had kids in high school, earlier. I don't know. My daughters have been out of high school for 10 years. Gives you it's probably about that long at least. It was revolting.
Mm.
It was absolutely a repellent flavor. The chemistry in it with the chemical patina, the taste was so strong. It was as if I was eating little chunks of solidified Febreze or hairspray or something. It was absolutely impalatable. I mean, spit it in the sink and run the garbage disposal level of it, not palatable. And so I wonder how much of it is exposure in the right place at the right time, with the right wanting, just like anything else. Like I know people who used heroin occasionally and then it never became a habit, or who used other drugs, hard drugs occasionally. Most of us use alcohol and don't become dependent upon it. So what is the difference? There has to be sort of the right situation and the right dosing, and probably some sequential building of tolerance to it over time. But if I mean, I had expectation. I mean, I had a positive expectation. I was open to a pleasant experience, and I found it rather shocking that the experience was anything other than that. And it actually the the chemistry prevented me from going forward. And I just wonder if there's something to do with maybe a sort of an abstinence-based approach to these highly processed, highly palatable foods. I think that may be a lot of it, because after 10 years of abstinence, I noted a very interesting reaction.
Yeah, I think this almost deserves, putting all of the behavioral approaches or pharmacological approaches on a chart, and then perhaps describing, as maybe a good therapist or physician would, like, here's where we need to start. Because I am a firm believer that if there are serious, noble assertions out there that we think this theory is valid, we think this cause gives you this effect. Well, maybe sometimes in some people, it does, but can we ever distill everything down into a theory of everything where we found the answer? A, I don't think that's likely. And B, instead of looking at even the percentages, well, 20% of people do it this way. Some people have the hard wiring, so this is more of an issue. And some people have this environmental upbringing, personality psychology, so they get hard by this. I think sometimes it's even more developmental, where, like you said, you haven't had this candy in 10 or 20 years. And maybe back then it actually tasted good because it was actually cane sugar and natural flavoring. Now it's just plastic with chemicals put on it. And so to you, it's revolting, but 20 years ago, it may have been great. Go
Well, I
ahead.
also think this is interesting too, because if sucrose were the driver, if sucrose were really the addictive driver by itself, you could argue that I would have kept eating it despite the negative consequences. Because what is addiction? We continue to consume despite negative consequences. That's very trite for what I just said. It's far more complicated than that. But it makes me stop and wonder if sucrose alone was what it took to get me to eat that, then that would have been enough because there was certainly plenty of it. It's basically all sugar and chemicals. But sucrose in and of itself was not enough. Now I know if I'd have gone and pulled out a Snickers instead, I think my response would have been a lot different, because there's a different kind of complexity in that, and there's textures, and there's some arguably somewhat more natural products in terms of cocoa and nuts and things like that. So flavors that we are used to, as well as they'll have their highly palatable stuff in there. But I think it's really it's fascinating. I don't discount the ability for people to become addicted to these highly palatable foods. I really think that chemistry is what's different than just sucrose in and of itself. And I think in a bigger picture, like, if that's how someone behaves, then maybe that's how you just need to assess them and treat them and work with them. If they feel that is their problem, then I think when we talk about how we work with, in clinical practice, and I'm sure Kevin will agree, when we're looking at shared decision making, then you respect that individual's assessment, and they come to you and you work with them, and you don't tell them, oh no, it can't be that. You just say, then you become curious and you get more information, and you say, well, we don't really know, but it's obviously the evidence is that it can be very individualistic. And if this seems to be a problem for you, then let's just work with it and let's see how we can help you.
That's exactly what I agree with when I said, Jen, and feel free to jump in here, Kevin, in having all the treatment approaches and methodologies and theories out there, and to say, okay, like, let's work on this developmentally. What do we think the biggest place to address would be? Because you even mentioned, Jen, abstinence. And research shows that if you abstain from certain foods, you're probably going to develop even more indulgence cravings, and that could create binging, because research shows if you just have those decadent foods in smaller doses more often, then you won't crave them as much. But not if somebody who truly does have a behavioral or chemical type addiction, maybe abstinence is for them the best. And I want to finish my own comments in a few minutes with how I see people who have seriously addictive genetics and patterns yet still succeed. Like, how do they manage these types of things even with food? But Kevin, you were going to mention something?
Yeah, and my apologies if this doesn't necessarily fit or seems kind of out there, but I just wanted to bear reinforcement of chemophobia. Like, just because something is natural or synthetic, just especially in the context of food behaviors and food dysregulation or relationship with food, a driver of that is how we label foods or how we deem what's good or bad chemicals in food that we eat, and etc. Just keep context in mind. Dose makes a poison. Cocaine is natural, so therefore go crazy if that's the case. Just keep in mind, what we are defining chemicals, what's good or bad should be neither, just context. The dose makes a poison. So I just wanted to maybe reinforce that because, yeah, I just feel it's important to emphasize.
And I think that could even come into play with the individuality. So the reason I like that they started with evolution is, to my point, that a truly evolutionary change that you see in most participants of a species may take 100,000 years or a million years. Well, along the way, there are some changes. There are epigenetic changes are occurring, and there may be a subset population that truly does feel like, or even has the biochemical reaction that other people don't. And so it could be that we are seeing the tip over to some of these hyperpalatability laden foods that do become more chemically addictive. And that's where I wanted to bring in Celestine's question about withdrawal, because this was the big point last week, was that people don't see sucrose related chemical addiction withdrawal symptoms. Now, physiologically, I would caveat that with, because of receptor site, insulin, glucose disposal, it can feel different, right? Like you can feel hypoglycemic, and you have these hedonic desires, and so you can feel these cravings that I just can't withstand. I'm spraying the cookies in the garbage can with Lysol, right? Like that certainly feels like addictive behavior, looks like addictive behavior. But in the mechanistic studies, they show it doesn't have the same opiate type thing. So that's where even the second group of researchers came in and said, okay, let's stop comparing this to cocaine and let's compare it to caffeine and nicotine. Much more subtle. That's probably where we are with the food stuff. But I go back to the point that these are both groups of people who are not sponsored and financially supported by DuPont or Hershey's. Like, they're public health researchers trying to find the answer. So I think it's important to kind of pull both toward the center and say, okay, you guys have some good points, some good ideas. Let's see, how this can help the most people. So that's where I still come back to Jen's point of the semantics. You know, I come from a family of massive addiction. I mean, siblings, uncles, parents, alcoholics, drug addicts, food addicts, 100 pounds of obesity, poor decision making, massive impulsivity. You could relate this to every kind of chemical addiction pattern, personality addiction, just bad environmental, habit formation. And here I am in this entire milieu of biochemistry and environmental circumstances. And at some point, I looked at that and I thought, I don't want that life. Like, that is not what I want. And luckily, I had or developed a level of conscientiousness in my personality traits to say, I got to extricate myself from this. So as a kid who followed in those footsteps, and I was extremely overweight, and I was not happy as a teenager seeing myself follow that, um, and I would say it was hard even physically. Like, I remember binge eating, I remember like overeating, and I remember saying through my own education and experience growing into adulthood, where I have had to instill, just by sheer will, temper myself against those. It's a constant reminder. Do I want to be healthy or not? Do I want to fall into these behavioral traps or not? I can't say I have any chemical addictions that would be the same as a true addict or not, but I sure know I can see in my whole family tree that we are in that cesspool to the nines. And yet, I have crawled my way out, and I think I've seen that in a lot of other successful people. Maybe not everybody, but for the people we're trying to reach, again, go back to those two main conclusion points of both studies. If it's an addictive chemical, we've got to treat it like an addictive chemical. If we say it's an addictive chemical and it's not, then we are going to ignore all of this other behavioral work that we can use to help people, and vice versa. So, to Jen's point and yours, Kevin, like, okay, maybe we need to be nuanced and individualize how we approach it. But it seems like the preponderance of evidence is we still have a lifeline primarily anchored in behavior, in habits, in education, in modeling and work and learning. But for those who really feel like it's chemical addiction, well, here we go. We have GLP-1s now. We have other pharmacological approaches that will probably be coming online, and maybe we'll have two different pathways, and it's up to the person. So final thoughts, anybody? Amy, Jen, Celestine, Becky? Don't want to keep you guys unduly too long here, but to me, it was a good juxtaposition, like to have these two kind of framed in here and have some good discussion. But we'll see if we get any comments or feedback. I'll make sure I post both of these in our chat, so company-wide, so people can jump in and discuss. All right, guys. Once again, thanks for hanging there with me with our schedule changes. I will chat with you guys soon.